You don't even need a graphing calculator for the things that we're doing today. You can use one, but you don't have to. Today we are going to solve systems of equations. You should have done this in Algebra 1, so this is a review from Algebra 1. First thing that we're going to do is draw some things in our boxes. So there are 3 different things that can happen when we are solving systems of equations. And so the first thing that I'm going to do is just write like an X and a Y. So I'm just making like an X and a Y. I'm just making an X and a Y. Take it off. Making just an X and a Y. And then I'm going to show you the 3 different situations. David, pull that earbud out. I know it's frustrating, but I need you guys to listen to me. At the end of class, you can listen to your music. First situation that can happen, and these are in no particular order. They could be switched around. I'm just showing you the 3 possible situations. First possible situation, and this is like what we did on the warm-up. It's you've got 2 lines. Here's a line. And here's a line. Just 2 lines. And what we're looking for is what happens. So for this one, do they intersect? Do the 2 lines intersect? Do they cross each other? Yeah, so another word for intersect would be, do they cross? Yes, they do. So where do they cross? Right there. That is your solution. How many times are those lines going to cross? Are they ever going to cross again? No. So there is one solution, and it would be X, Y. So solutions, yes, there is one, and it is X, comma, Y, whatever that point is. The next situation that can happen are these 2 types of lines. Are those lines going to intersect? No. Why? Yeah, they're parallel. Parallel lines don't intersect. So how many times do they cross? Okay, so how many solutions do we have? 0. There are no solutions. And one way that we can say that is with this symbol, like this. It means no solution. It doesn't mean 0. It means no solution. Bless you. The next situation that can happen is kind of a weird one. So here's the next situation. So here's a line. And then here's another one. So that's actually 2 lines. Yeah. So that situation is actually kind of another weird situation that they are the same line. The same line. So how many times do those lines touch or cross? Where do they touch? Where at? Everywhere, right? If they're the same line, I mean, they're like technically like touching here and here and here and here and here and everywhere, right? So how many possible solutions are there? Infinite. Yes, there's infinitely many. So intersection, yes, everywhere. How many solutions? Infinitely many solutions. Infinitely many solutions. So as we're going through the stuff that we're doing today, we get one of three answers. We either look at the graph and the graphs cross and we go find the point where they intersect. They don't cross because they're parallel lines and we say no solution. Or we go to graph them and we realize they're the same thing and we write our answer. It means infinitely many solutions. Most of the time we get situation number one. You graph it, two lines intersect, we find the point. That is most of the time what happens. Yes. Yep, take the class. We good? Can we move on? Sure. So the next thing that we're going to do is go on to example one, and we're going to graph those lines. And so if I was you, I might take a look at those lines and see, can I graph them? Oh, sorry. You can graph the first equation. The second one, I have a correction. You ready, Terrence? All right. I changed this equation, so scribble it out and fix it. Scribble it out. This one's better, I promise. So when you go to graph this, I'm going to I start with the thing without the X. That is our y-intercept. So for my first line, the y-intercept is 1. So I'm going to go put a point at 1. Then I apply the slope from wherever my y-intercept, I apply the slope. For this one, it's 2. It doesn't show, but it's the same thing as 2 over 1. If you want to go put over 1, that's fine. So from your point, you always go up unless it's negative, then you go down. So I'm going to go up 2 and then over 1 and put a point, up 2 over 1 and put a point. Once I connect the dots to the right, I'm going to continue the pattern to the left. So yes, I would have to go down 2 and over 1 to continue the pattern to the left. As soon as I have enough points, then I'm going to take and I will connect the dots. If you like your lines to be nice and perfect, I do have straight edges up on the top right table, but I don't care if they're perfect. Really, what we're looking for is the intersection of the two lines, if there is one. So for my second line, yes, I go put a point at -3. From that point, this tells me that I'm going to go up 2 over 3, up 2 over 3, up 2 over 3. So I'll connect the pattern, go down 2 over 3. Connect the dots. Do you see the point where they intersect? Yeah. So this is like that first situation where we definitely have an intersection. It's right there in pink. How do we name that point? What is the name of that point? To name points, we have to do X comma Y. So we have to first look in the X direction. How do I get to that point from here? How do I go? -3, and then I can do the Y. -5. A point will have parentheses. That is my solution. The entire front of your homework is doing just that, graphing the two lines, seeing if they intersect. No, this is all we're doing. So the next one, we're going to have to graph these. Let's start with the first one. So the first one, it looks like that I'm going to go put a point at 2, and then I'm going to go up 2 and over 5. So I'm going to do that up on the board. Let's see if you can graph just the first one. Just the first one. Let's see if we get the same looking graph for just the first one. So once you graph it, look at mine and see if ours looks the same. For what? For the first one or this? Are you working on the first one or the second one? Okay, for the second one, we'll get to the second one in just a second. This first one, did we all get the same thing when we graphed it? Awesome. So for the second one, is it in y equals? No, we could get it in y equals because we've been doing stuff like that. To get y by itself, don't I just take this 2 to the other side? Yeah, so I would just move the 2. So I would add the 2 to the other side. Now I could graph it. So if I graph that one, I'm going to go put a point up at 2. And then I do the slope up 2 and over 5. What do you notice? Yeah, it's the same line. What is our answer when you have the same line? It ends up being the same line. And we say infinitely many solutions. That is our answer. Infinitely many solutions. Yeah. So well, for this one, there. I know this is the same line. Oh, are you asking about this one? Okay, so our answer is the XY, that point of intersection. The answer is the point of intersection. Yes. So another way to describe that point would say X is equal to -3, Y is equal to -5, or that point. Same thing. There are some questions that you might come across and it might say, what is the Y value of the solution? Well, the Y value of the solution is -5. What's the X value of the solution? It is -3. But in general terms, if I'm asking you to find the solution, I'm asking for that point of intersection. We're going to do more of that. We got 4 more examples. In fact, the front and the back of this notes is all practice graphing lines. Except for I forgot to copy it open. Next example. So we're going to come over here. The first one, I'm going to go put a point at 7. So I'm going to draw, I'm going to go put a point at 7. 7's at the very end of my graph, but that's okay. And then it says that I need to go up 6 and then over 4. If I go up 6 and then over 4, I'm off of my graph, right? Okay, well, could I go down 6 and over 4? Sure, I'll do that then. So down 6 and then over 4. And I could do that again, down 6. Yeah, it'd be like right there. So I could connect these dots. There's my first graph. For my second graph, I'm going to do the same thing. So for this one, I'm going to go put a point at -5. And then this slope says that I'm going to go up 3 and then over 2. Up 3, over 2. The solution is where our graphs cross or touch or intersect. What do you mean? So you always start going up and to the right. Sometimes you go down, and that's only if your slope is negative, but you always start to the right. Because we read books from left to right, so you always start and then you go to the right. Well, what about way off in the future? Are they going to cross then? No. And the reason is, well, what about this fraction? What is 6 over 4 reduced to? 3 over 2. So it's because they have the same slope. So these will never intersect. There is no solution. And we can also use that symbol like this. The slope. So the top one is up and down. And then the bottom one is left and right. Yep. It's the opposite of when you graph a point. When you graph a point, you do X comma Y. It would have to have a negative there. So we haven't graphed a negative line yet. The negative will just be out in front. We're gonna graph one with a negative, I promise. I'll show you. The next graphs, we'll start with the top one. This one's different. It just has a y. A y equals -1. Is there any x at all? No, just the first equation. There is no x. Well, we know that when we're graphing these, we can start with the y-intercept, and there is a y. So what we do is we go find y is equal to -1. So this is the y-axis. I'm going to go down here to -1, and I put a point. There's no x, so you don't go up and down at all. It means y is -1 all the time. So you end up with an equation or a graph like that. What if I had just x equals a number? What do you think you do if you have x equals a number? You start from where X equals whatever that number is, and your line ends up looking up and down. So if it's X equals or Y equals, you chop through whatever axis that is. So this one is a Y equals equation. So you chop through the Y axis. If it's an X equals equation, you chop through the X axis. This one is another one that isn't as Y equals yet, but could we make it Y equals? Don't we just need to bring the 6X to the other side? Yeah, so we need to subtract 6X to the other side. Normally we have the X term written first. So if you want to, we could rewrite it. So it'd be negative 6X minus 7. I'm going to squeeze it in right there, so that we have everything looks like everything we've graphed before. So we're going to do the same process. I'm going to go to negative 7 and I'm going to put a point. I'm going to go put a point at negative 7. And then I'm going to apply the slope. For this one, this is the first one that we've had as a negative. If you have a negative, it always goes with the top number. It tells you whether or not you go up or down. And there isn't a bottom number, but we know that it's the same thing as over 1. So this one says that we're going to go down 6 and then over 1. Well, if I'm already right here, I'm already at a graph to go down 6 and over 1. But I could go up 6 and then over 1, right? You do always go right. If I went right, I would have to go down 6 and then over 1. I'd be way down there. So see how my graph would go down 6 and then over 1, but I'm off the graph. So I have to make. Well, you go left and right. No, you always go to the right, but my graph is not there. So you still could plot a point going down 6 and over 1, plot a point. And then to make the other half of the graph, you can do the opposite. So you go up 6 and to the left to make another point. And then I could go up 6 again and make another point. My graph would be like this. Sorry, I had to draw mine in sections and it's not too straight, but I had to do the best I can. Do you see a point of intersection? The lines don't cross? That is a point of intersection. This is a cross, right? So the point where they cross, that is an intersection. So think about the intersection on a road. It's where two lines cross each other. So the intersection is right there. And I think I heard it. How do we call that? What is the name of that point? -1, -1. Or X equals -1, Y equals -1. So the point is -1, -1. How do y'all feel so far? Horrible? I know a lot of you guys did stuff like this when you were like virtual and things, so it was tough. We didn't really, it was a rough thing for us. Some of you guys are kind of struggling, so I feel like we should probably take a brain break. Huh? No. No. You mean getting a lower score? Well, it was even worse than that because they got like 500 points before that. They were not happy. Oh, is it empty? Throw it away.
Grammarly's 5 tips for writing a professional email. Email writing is super important. Grammarly's 5 tips for writing a professional email. Email writing is super important.
Come on, Charlie. We got you. Name something specific, name something specific. Pirate might have. I think that's Jules. I think that's Jules. I think that's Coins. Yeah, I was thinking that. Bones. Those are. Pearls are jewels.
What else? Nine pence? Gobbler?
Oh. What is a grog?
You only wanted this first page, right?
What do you mean?
Just this page, just this one.
Probably, I'm not sure.
I finished it though.
Okay.
I didn't like it though. It's rum.
We have to know so good.
That's what grog is?
Rum is rum.
That sounds awful. Let's do another round. Other than food, name something that babies like to put in their mouths.
Toys. Utensils. I mean, my sister, my other sister, and oh,
I think that's toys.
tools.
Got hands to, that's what I chose and it said fingers and toes. What?
Ooh.
Well, we said pacifier. Oh my goodness. I feel like we said pacifier. That should have been that.
Eating room, I feel like.
Yeah, why not make it this one?
Right. Right. I feel like
We'll have to get like first answer on everything on like that one.
Thanks, Mr. Warren.
you're welcome.
I'll see you in the event.
No. Monday.
No, Wednesday.
Oh, yeah.
Yes. Take the pass. All right, for the next one. We're on to the back. A system of linear inequalities. So anytime you have inequalities, you have something that you would be graphing. So we did inequalities and we graphed it on a number line. We graphed our answer. Now we're going to have inequalities that are lines. And so we're going to graph the lines and we're going to shade the lines. Instead of shading a number line, we're going to shade the lines. So the solution to a system of inequalities will be the overlapping shaded region. And so that's what I'm going to write down. The overlapping shaded region. A couple of things that we need to remember. We need to remember when we're graphing lines, whether or not we make them solid or dashed. So we will have solid lines when we have a solid line underneath the inequality symbol. And so I'm going to put this in this little space right here. I'll put some notes because we don't need a whole lot of space to answer that question. So when we have something underneath our inequality signs, those are going to be solid lines. So that we're going to graph a line and it will look like that, a solid line. If we have nothing underneath, then you will have a dashed line. So it'll be dashed like that. So you either have a solid or a dashed line. And when you have a solid line, anything on the line is included. So you can add that. I'm going to say point. Yes. Any point on the line is included in the solution. So any point on a solid line is included in the solution. That means any point on a dashed line, not included. Not included. Okay, points on a dashed line are not included. There's a couple other things that we want to review before we actually go to graph. And so when we go to graph, we're going to be shading things that are greater. And so we have a greater symbol, and sometimes we're going to be dealing with, so these are things that are greater. When we have things that are greater than, you could have a line that is like this, or you could have a line that's like this. So one is positive and one is negative. You could have one of each of them. And if you're shading it, if you are shading above, greater means above, you shade like that. That's above. This is above the line. Sometimes you have less than. So less than. And it doesn't matter if you have a positive or negative line. Less than will shade below. Do you guys see that that is either shading above or below the line? Jaden, you gotta put your Chromebook away. We aren't using Chromebooks right now. We're taking notes. You can check them when we're done with our notes. We only have a couple more problems. So greater or less than. And so these are really good reference guides for you. So don't lose these little sections. So now we're going to go to graph these lines. So for this one, I'm going to graph the line the same way that I would before. The only thing I check on is whether or not I'm going to be solid or dashed. So for this one, is there anything underneath the symbol? So what type of line, solid or dashed? Dotted, dashed, yep. What about the bottom line? Solid. Okay, so when I go to graph this one, the first one, I have to go put a point at -3. And then my slope tells me up 1 over 2. So I'm going to go up 1, then over 2, put a point. Up 1, over 2, put a point. So if you want to, it just depends. You can kind of make it like that. You're gonna just dash it across. Like that. I have a dashed line. And then I have to do what? I've got a lot of points. I'm confused by your question. So I go put a point at -3. And then I have to go up 1 over 2, up 1 over 2, up 1 over 2, and then I go the other direction. And make a bunch of points, and then I just kind of made dashes at the points. You can put them wherever you want to. You just have to have a dashed line.
I mean, like, I moved it up over to us, then also got it, but
At the -3, it's this number. From there, we need to shade. So which symbol is this? Also, I can put the symbols up here. So greater would be this symbol, less than is this symbol. So is that a greater than or a less than symbol? It's a less than symbol. So our graph kind of looks like this one, right? It's a positive. So it's going to shade below. It's going to look like that. So I'm shading below the line. Now I'm going to go graph my other one. My other line. What? And I wouldn't shade it like solid. You just want to put a couple lines there to see where it's going, like where it is, because then we'll shade something solid in a second. Don't shade that solid. The next line, and this one will be solid. We go up to and we put a point. That, do what? Good question. So -x is the same thing as -1x, and any number you can put over 1. So it's like down 1 over 1. So we go down 1 over 1, down 1 over 1, and we keep going. This one's going to be a solid line. And then does this symbol tell me that I shade above or below? Is it greater or less than? So I shade above. And so if I'm shading above, I have to shade right here because that's above the line. Can you see the overlapping shaded region? Can you see where the two shaded regions overlap? Yeah, so that little triangle, that's my solution right there. And if you want to illustrate that by highlighting it, you are welcome to. That is our overlapping shaded region. That is the overlapping shaded region. The question says, using the system and its graph from example 5, so we just did it, determine if the following points are part of the solution set. So remember, the solution set is just the overlapping shaded region or any numbers that are along that solid line that's bordering the shaded region. So let's go plot these points and let's see. 3, 1. Let's go plot it. We'll go over 3, up 1. Is that in my overlapping shaded region?
No.
No. We could say no. The next point, I've got 5, -3. So I'm going to go over to 5 and then down 3, put a point. But it's on the line. Very good. Yes. So it works. And it's on the solid line that's bordering the shaded region. Just because it's a solid line, if it's up here, it doesn't work. It has to be the solid line bordering this shaded region. So 6, -2. So 6, I'm gonna go down to -2. Does that work?
Yes.
It works. And last, I've got 6, 0. What kind of line? Is it on a solid or a dashed line? So does it work or not work? No, this one does not work. No. Let's finish our game. Something specific that is a hassle to replace when you lose your wallet.
25. Social.
I feel like that's your ID. Why is that not your ID?
No idea.
Good job.
Hey. One more.
Let's do fast money round. People could have a spare body part. Name something you wouldn't mind having an extra one of. Uh, Mrs. Claus put Santa on a diet because he no longer fits into. Is that how you spell it?
N-E-T-E-Y.
Thank you. No, please.
Oh my goodness.
Sorry, those were hard to read and understand. Well, your other score was better. We'll leave it. We'll leave.
I think we were still up though.
No, it was 12, I think.
Yeah, we were still in second. Even
Yeah, I'm not gonna change it.
This new one.
We only have 2 more examples to do. So when we go to graph the first one, and it's a good idea to identify whether or not you're going to make a solid or a dashed line. So the top equation, is it going to be solid or dashed? Solid. And then the bottom equation. What? Yeah. Okay. When I go to graph that first one, gonna go put a point at 2. And then this is just like our other one. I don't have a number there, but it's the same thing as 1 or 1/1. So you can add it if you want to. So it's negative though. So negative means I have to go down 1/1, down 1/1, down 1/1. Another trick you can do to save yourself time is that you can go down more than 1. You could go down 4. You just have to go over 4. So sometimes I just go by 2s. Go down 2 over 2 to make it a little faster. And this one's solid, so I'm going to make it a solid line. And now I have to shade. So this one says I'm going to shade below. So if I shade below, Below that line is down here. That is below the line. The next line, I'm going to go put a point at -1. My slope is 3, or 3 is the same thing as 3/1 if you need that. So that means it's positive. So I go up 3 and then over 1. Up 3 and then over 1. I can continue the pattern to the left, going down 3 and over 1. This one's going to be dashed, so I make sure I dash it. And this one is shaded less than as well. So, good question, right? So here's one way that you can always start if you're really confused on how to shade it. So you can always start out with a line like this. You know that that's above and that's below, right? Okay. So we know we're going to shade below. So my fingers are pointing below. Now I need to make my arms face like that line. It just happens to be really steep. You shade right here. That's below. And you can look at your little cheat sheet up there too. Do you see the overlapping shaded region?
No. Oh, yeah.
That is my overlapping shaded region. So sometimes they will even take off these things and they don't even show them. Sometimes they only show that part. It means the same thing. You don't have to show all the other lines, but I have to do it to be able to graph it. We have one more example and then you'll be able to start your homework. So the first line, is it going to be solid or dashed? Solid. Do I shade above or below? Above? Dash. There's nothing underneath. Okay, what about the second equation? Solid. Do I shade above or below? I don't think so. Below. The way we read these graphs is like this from the Y. So if the Y goes into the alligator mouth, it's greater and you shade above. If you go into the point, it's less than, so you shade below. For the first equation, you go find 1 and you put a point. From there, it has the same slope again. Negative x is the same thing as -1/1. So I'm going to go down 1 over 1, down 1 over 1, or I could go by 2s. I just got to go down 2 over 2. It's the same thing. This one will be a dashed line. And I shade above. So shading above looks like this. For my second line, I'm going to go put my y-intercept at 2. That one has a slope of +1 or +1 over 1 if you need to write it as a fraction. So I go up 1 over 1, or I could go by 2s, up 2 over 2. This one is going to be a solid line. And I will shade this graph below. Can you find the overlapping shaded region? Can you not see that these have both lines in it? Yeah, the overlapping shaded region. Okay. Alex and I were wondering, like, is she messing with us? Is that what you were wondering, Alex? Like, is she messing with us? That's my overlapping shaded region.
So it's just a negative variable by itself. Yes. What would we want?
Anything can be over 1. If there's not a number in front of the variable, it is 1. So how much time do we have? It is 3:50, so we have 25 minutes. You give me 10 minutes. And I'll give you the rest. So 10 minutes, keep your phone away. Yeah.